All right, well, thank you for joining me today. I don't think we're going to have time to finish this activity tomorrow during class, so I'm going to go over a couple of examples, or I guess to figure out the answer so you have that to know whether or not you are correct or not. This is the buried treasure problem that we talked about during class. You can't really see the worksheet unless you have it in front of you, but I kind of made a little grid here on where the oak tree lies, where the gallows lie, and where the pine tree lies. So I'm just going to go ahead and read the directions from now on and walk through you step by step on how to get each answer, or how to actually to find the buried treasure alone. So the first thing I need to do is find the number of steps from the gallows to the oak tree. So what I mean by that is I want you to find the slope from the gallow here to the oak tree that's up top here. Well, if I want to figure out that slope, we know that slope is rise over run. So I'm going to rise how many and then run how many. Well, let's see. I rose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I ran 1, 2, 3, 4, 5. So right now I rose 11 and I ran 5. But you got to be very, very careful here. I have to notice, okay, is my slope positive or negative? Well, that means a big difference here. So let's first look at the oak tree. I like to start with my most left point, and I say, okay, this is my most left point up here at the oak tree. Now, how do I get from the oak tree to the gallows? Am I going up or down? Well, I am going in a negative direction from the oak trees to the gallows. So this arrow here, if I were to draw an arrow, will be pointing down. So I know my slope is negative 11 over 5. And I want to turn 90 degrees. I just found that slope. Now I want to rotate 90 degrees. So if I start from the gallows and I walk to the oak tree, I need to first turn my body to the right 90 degrees and then walk the same number of steps. Well, that means that this distance from the oak tree to the gallows has to be the same distance from the oak tree to my nether point, which is going to be labeled spike 1. Because after we find that spike, or after we find that, or after we find the slope, we're going to record that spike below. So, well, I need to make a 90-degree angle from this line here. So just act like this line would extend all the way up here. Well, a 90-degree angle, we know we can just take the opposite reciprocal. Well, what's opposite of negative, which is positive? And the reciprocal means I flip my 11/5 and it becomes 5 over 11. Well, now I start from my oak tree. Since I'm going 90 degrees, I need to go up 5. 1, 2, 3, 4, 5, and then run 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I put a point. Now I freehand drew this, so you should kind of see, that's actually terrible. It's really hard to draw with this. But this angle here should look something similar to a 90-degree angle since we did in fact rotate 90 degrees. In this, I'm going to label it as stake. What did I call it? Stake. What did I say? Hold on here. Let me read it. Actually, it's not even stake 1. We're going to call it spike 1. Let's call it spike 1. Spike 1. Now I do the exact same thing from my gallows to my pine tree. Well, what's the slope from my gallows to my pine tree? I always like to run right. I don't like to run to the left. So I like to go up or down depending on positive or negative and then run to the right. So I'm going to start with my pine tree. I'm going to find the slope here from my pine tree to my gallows. Well, I rose 1, 2, 3, and I ran 1, 2, 3, 4, 5, 6, 7, 8. So my slope is going to be 3 over 8. Now I have to stop and think, okay, is this slope positive or negative? Well, again, I start with my most left point, which would be my pine tree. Now, did I go up or down to get from my pine tree to my gallows? Well, I went up, so this slope must be positive. Now, if I need to find the opposite reciprocal, opposite of positive is negative, and I flip-flop my 8 and my 3, and I have negative 8 thirds. Now, another thing I'm going to point out right here is I like to write my negative out front. I like to write my negatives out front of my whole fraction bar. I don't like to attach them to an 8, and I definitely don't like to attach them to the 3. A lot of you guys are getting confused with up here, if you would look back up here at my first slope, if I had negative 11 over 5. Well, you take the opposite of negative 11, that's positive 11, and then you take the opposite of 5, which becomes negative 5. Well, negative 11 over 5 and 11 over negative 5 are the exact same things. These are the exact same things, and it gets a little confusing, so I like to write my negative out front there. That way it's easier for me to understand on what I'm taking the opposite reciprocal of, so I don't get that mixed up. Okay, so now I know it's negative 8 over 3. I always like to run to the right, so I know I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8, and then run 3. 1, 2, 3, and I'll put my point here. And this line right here should make, again, another 90-degree angle or something that looks similar, which it does, so I know I'm okay. And I'm going to label this spike 2. Now it says reflect spike 1 over the line y equals x. Well, y equals x has a slope of 1, so I start at my origin, and I go up 1 over 1, and I put a point. Up 1 over 1, and I keep putting a point. Up 1 over 1, up 1 over 1, up 1 over 1. So it looks something very similar to this. I'm actually going to make it, or save some time here. I'm just going to pick a line. We'll make it red. And I'll start down here, and I'll run this line over this point right there, and I'll just stop right there. Well, since I'm reflecting over just spike 1 over the line y equals x, I can count the distance I am from spike 1 to my line. So count diagonally. So I went 1, 2, 3, 4, 5, 6. Well, I have to go 6 more. 1, 2, 3, 4, 5, 6. And I put my point here. So here's my point, and I'm going to call that spike 1 prime. Well, now it says I'm going to do a simple translation of spike 2 with the vector 13, 5. So I have the vector 13, 5. Now I move left to right on my x-axis first, which is 13, so it's plus 13. So I go right 13 and then up 5 since my 5 is positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I go up 5, so it's 1, 2, 3, 4, 5. I put my point here, and I label this spike 2 prime. And it also says I know the treasure is located halfway between the distance of spike 1 prime and spike 2 prime. So again, I'm just going to freehand draw this line right here, and I know my treasure is located somewhere around here, about halfway. So to figure that distance out, let's just find the slope of this whole line. Well, the slope is up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I ran 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the slope from spike 2 prime to spike 1 prime is just 10 over 10. And I know that's positive because I picked my most left point, and I'm going in an upward motion, which makes that positive. Well, if I want to find, or if I know the treasure's halfway between both these spikes, let's just take half of my numerator and then half of my denominator, and I end up getting 5 over 5. So if I go up 5, 1, 2, 3, 4, 5, and then I run 5, 1, 2, 3, 4, 5, I know my treasure is going to be located right here, and that coordinate is negative, ahead of myself. I know that coordinate is going to be located 9, negative 3. So if you ended up getting a solution of a buried treasure of 9, negative 3, you know you did it the very correct way. And if you have any questions, please, like always, bring those into class tomorrow, and I could help you, or Mrs. Rothen could help you with those. Thanks for watching. Have a good evening.